When
When you are able to see my screen, please let me know.
not it, not it, not it. Yes.
So today we need to discuss about
Ah,
data flow and communication patterns.
right. Beautiful. Okay.
Okay, so what do you understand from this? What do you understand from this title, module title?
Okay. Data flow is like, for example, in with an example of a boutique example, if we take the customer just first he logs in, then he browses our product, then he selects a product, and then he places an order, then he makes a payment, and then the product is delivered. So this is the flow I can think of. That is the data flow, because everything has to go in sequence. I cannot directly first ask him to do the payment, nor I can enable the delivery services without he selecting the order. So customer logs in. Without logging in again, he cannot log in, see the products, select a product, make the payment, then delivery. Then other small processor, I update stating that this order is delivered, and my inventory comes down by one number. For example, one number is place an order, my inventory comes down by one number. So this is the flow from beginning to end, within a broad perspective.
Yes, yes, yes. So in normal term
Ah,
means data flow,
ah,
means how data will flow
ah,
in our system, and communication pattern, how means we can communicate.
ah,
Simple term. There is
okay.
no complicated thing. Simple
Mm-hmm.
communication. We need to communicate with our system. How
Ah,
we can communicate? What are the ways are there? What are the pros and cons? We will discuss.
okay.
Okay. So right now, if we talk about communication,
Hmm.
data flow and communication, these are the two ways: synchronous versus asynchronous communication.
Okay.
What do you understand from this? Synchronous and asynchronous. No.
So okay, the synchronous is like what you say, happening then and there. Asynchronous is happening in the background. Again, quoting our project example, asynchronous, for example, once the order is placed, the updating of the inventory is happening is in an asynchronous mode. That it just happens in the background. Synchronous is, I think, the payment. Maybe I'm thinking synchronous. That also happens in the background. Uh, Synchronous, asynchronous. Uh, Something happening in the background is, I think, asynchronous. And synchronous example, which happens that moment live online. Mm, Sorry, Deepak, I'm not getting any example, or not able to explain clearly.
No worries. So synchronous means it require one another one in a sequence manner. It will follow
Oh,
a sequence.
okay, okay,
Okay.
okay.
Means let's say if something is started, then it need to be end, then it's moved to a next point.
Oh, sequence. Oh, okay, okay, okay,
As
okay.
normal English
Ah,
sequence. It will
ah.
follow the sequence. Okay.
Okay, okay, okay,
And asynchronous means it will means require some time
okay.
to get a response. So
Okay.
it will means rather than waiting
Ah,
for that, we will say, hey, you will require some time, take your time,
ah.
we will move ahead.
Okay.
Makes sense.
Okay, 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 okay.
We will not wait for the response. It
Ah,
will, we can move ahead.
okay.
Okay. Let's say, as we discussed earlier, means like chef is preparing a dish,
Ah,
and he will meanwhile he is waiting for a
ah.
boiled water. He will chop the veg and things
Okay,
or do other things
okay,
rather
okay.
than waiting for just
Ah,
waiting.
Okay, okay,
Okay,
okay,
that's why synchronous.
okay,
Okay. Okay, what is request response and event driven flow? What to understand from this?
okay. Request response and event driven.
Divide into two parts.
Yeah,
Small. First this, then this.
okay.
Then we will compare both.
Fine, fine. Okay. I think the request response, I can think of, I requested for a product to be bought, and the system responded by saying, yes, inventory is available or something like that. My request was for a product, and I got the response available. And then event driven. Okay. Now, yeah, my delivery gets enabled after the event of the payment being done. So payment done is an event. Once that event completes, then I trigger the delivery part of it. Till then, that is waiting. Delivery part is just ready to go, but it requires a green signal from the payment facility. So once that happens, so that event, payment is an event. Once that event sends a signal, my delivery starts. That is event driven flows. Am I right? Or somewhere near I am?
Yes, yes. But and what is the difference between both? Because we need to tell verses as well.
Okay.
Consider verses as well.
This is okay. Okay, event driven flows happens in the background, whereas request response happens that moment. Uh, I know I'm not that clear. Uh,
Okay.
okay, for example, there are 10 requests coming in a minute, but they will be in a queue based on whichever response completes its work. Then the event of payment takes place. From the event of payment, then delivery takes place. So request response is immediate. Even no versus event driven. No, I'm not able to put in simple terms.
Simple term request. You requested something.
Ah,
When you will get, then you can means move ahead. You
okay.
cannot means if you will not get a response,
Ah,
you will still in a waiting mode
mm,
because you already means let's say you already gave a exam and you
mm,
are waiting for a result.
mm.
And if you're not getting a result, you cannot move forward.
Correct.
Makes sense.
Right, right, right.
But event driven is a thing. Let's say you will kind of there is a one publisher and there is a subscriber.
Ah, ah,
If subscriber means show his or her interest in that particular publication or like a magazine or a newspaper subscription or any another
ah.
subscription, he will get the things means for whatever publisher is publishing.
Okay.
And for that he need to wait.
Okay.
When publisher will publish, then it will get the things.
Okay, okay, okay,
That's why event driven.
okay, 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 okay.
Okay, here means it's totally up to you. Means you will till that time you will stop your work or you will continue with the other
Mm.
things.
Okay, okay, okay.
Like for you can consider your boutique itself.
Ah,
Like whenever status is updated, then you will get a new message or email. Hey,
correct.
now status has been updated. Now you can
Right,
check.
right,
Make sense.
right, correct.
But in a response request model, you need to wait.
Correct.
Okay. So now let's move to a data ownership and data movement. What do you understand from this?
Okay. Data ownership, data movement. I don't know, again, in the simple terms, data ownership. Whatever products I am displaying or the inventory, what I have is uh, I own that data. There is data ownership, and then data movement. In simple terms, data moves movement from one. Okay, data movement maybe from one state to another state. That is data. Yeah. Now.
Think in a
Ah,
normal
ah,
way,
okay. Okay.
without any stress, without
Okay.
anything.
Okay.
Just divide whatever means sentence you have
Hmm.
broken into you can say words,
Words.
and
Okay.
think about words only.
Okay. Okay. Okay, data. Okay, okay. Now only data movement. It is nothing but movement. I can term it as different state. For example, inventory was 10. Now it moved to 9 after an order got successfully placed. So change of state is, I think, can be termed as data movement. Data ownership is whatever data lies there in the system. I own the data. It is all my data. Uh, is my explanation. Maybe.
So, like you can say, you can think of data ownership.
Ah,
Hey, I am running a, you can say, this boutique, and
ah,
I have a ownership of my all the resources with
ah,
me.
ah, ah.
Even though it's you can say my you can say products are there, so
Mm,
single source of truth should be there.
mm, mm,
From where I will means from where I will purchase the
mm,
you can say clothes,
mm, mm,
from where I will you can say get the you can say resources or items which I require to means stitch
mm,
the
mm,
clothes. Am I
mm,
right? So
mm.
everything should be means ownership should be there.
Ah, okay.
If we are changing this tomorrow, today, let's say we are making a system and we are changing this data sources frequently and ownership frequently,
Mm,
then is you can say how it will accommodate. Means
mm,
that
mm,
time maybe you will get required things or not on time or not.
mm, 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 mm.
Makes sense.
Right, right, right.
And data movement is nothing like as its name suggests, it's moving the data. As you said, means a state.
Ah, ah.
Means when it's moving, what is there on what state? Let's say on a clothing. If you talk about when it's a raw, means it's a cloth only.
Okay,
Then it's a pre-state only, and when it's you can say go for stitching, go for cutting for
okay.
a particular size.
Right.
So there is another movement.
Okay,
Then it's a go for a stitching.
okay,
Then stitching, then test means after stitching, then it's go for boxing and things,
okay,
delivery.
okay,
So how data moves step by step.
okay, okay,
You can say baby step.
okay, okay, okay.
Okay.
Right.
Okay. Handle partial failure in communication.
Ah, ah.
What do you understand from this point?
Failure, for example, after an order is placed, uh, after an order, the customer goes for payment, but due to some network issue, there's a payment failure. Or he places an order, but the inventory doesn't get updated, or the order itself doesn't get placed. So like this, there can be many failures. Or after the payment is done, we generally trigger an update for the delivery team, but the update doesn't happen. So the delivery team doesn't know that they have to deliver this product. So failures can be at many levels, at different levels, at different events. So that is the failures.
Okay.
Or
Yes.
the very basic step like bringing up the products itself may fail because of some network issue. My boutique may not show the products what is available in my store.
Yes. So here means it's handling partial failure.
Mm,
It's
mm.
not a complete
Not
failure.
complete failure. Yes.
So first thing we need to know is not a complete failure.
Ah, ah,
It's a let's say you are means we are communicating with
ah,
each other,
ah, ah, ah.
and due to any reason I will take a some pause.
Pause. Ah,
Farah, you can say second.
ah, correct.
Then you are whatever you will thinking means what happened with Deepak, something like
Mm,
that. This is a partial failure,
ah,
and we
ah,
need to think about that as well.
okay, okay, okay. Okay.
Let's say this in a request response, if there is a delay in a response, what
Mm,
happened? Okay.
mm, mm,
If let's say me subscriber is you can say not you can say subscriber not able to receive the thing, what
mm,
happened? So, sir,
mm.
you can say not completely, but partially.
Right, right, right,
Okay.
right, right.
So, do you have any concern for these topics, or could we move to so that if you know, if no, we can move to a theory part.
No, no. I mean, with your explanation in this simple manner, I'm able to get all the stuff what you displayed, Deepak. It's nice. It's okay. I'm able to understand. We can move next theory part.
Okay. So today I will come up with the new things. So hope you like that.
Ah,
So right now, rather than going through code, let me do this. Just a minute. Let me. And Sridhar, if you have any suggestion, please feel free to do that. Okay.
okay, okay, Deepak.
Don't wait means
Okay, okay. Right, right. Got it.
because you are learner there, so you need
Ah,
to means come
right.
up with the things. Hey, Deepak, this will not work. Could we do these things or not? So right
Okay.
now you are. This is our thing.
Ah,
Why this module matter?
ah,
Focus on a whole system communication and exchange data.
data. Right, right.
Most large-scale system failure are not caused by bad databases or bad code. They
Ah, ah,
usually happen of
ah.
wrong communication pattern,
Yes.
unclear ownership,
Ah,
poor handling of failure,
ah.
misunderstood data movement.
Okay.
Make sense?
Right.
So means system designing matters.
Ah,
Make sense?
ah.
This module helps you choose the right communication model based on a latency, reliability,
Hmm.
scalability, failure tolerance.
Tolerance. Okay.
Real life memory hook. Think of food delivery system. Customer
Right.
place order,
Ah,
app validate request,
right,
kitchen prepare food,
right.
delivery partner gets assignment,
Yes,
user receive updates. If
yes.
communication is poor, the whole system become confusing and unreliable.
Right.
So synchronous versus asynchronous communication. But
Yes.
synchronous communication means the caller wait until the response come back.
Comes back. Yes.
Okay.
Yes.
And asynchronous means the caller does not wait
Yes.
and the work continues in the background.
Yes.
Okay. So, but keep this thing in mind.
Ah,
Let me tell you in a real scenario how
yes.
you will means make sure whatever means you will whatever task is going on background,
Ah.
and when you get a result of that task, how you
Okay.
will means make sure that's the same result which you are looking for,
Ah.
and you start in a you can say past, you
Mm-hmm.
started in a past, how
Mm.
you will make sure that
Right, right.
what is the way there,
Uh,
could you think about this?
on asynchronous communication means caller does not wait and like I told you, for example, once the payment is done, once the order is delivered, then in the background my inventory gets updated. The quantity comes down. So that happens in the background.
No, I am saying,
Ah,
let's say
ah,
you started something means for you can say since morning you
ah,
start
ah.
since morning you started something,
Okay,
now it's completed now,
okay,
how you will know that such, let's say you started 10 things
okay,
and means five things are completed.
okay.
Let's say you will think about, let's say you will give a, you have a 10 workers, you give a 10 different tasks to a
That's to them.
different
Right,
workers.
right,
Okay.
right.
And means first worker done is task.
Mm,
Okay.
mm.
How you will know means this is task done by this worker only, because you give a task to 10 worker and all 10 workers have a different task. How you
Ah,
will know?
ah,
And now means this particular task has been done is done by, oh, this particular task has been done, not
okay,
worker.
okay,
How?
okay. Uh,
Because this say this thing it will run in a background is easy, but how you will identify?
okay, okay. I mean, how identify? Mm, okay, for example, I mean again, because we have been using a lot of flags in the system. For example, when in the morning when I assign the tasks, okay, I keep a flag called completed as a default. I'll keep it as no, no, no. For the n, I'll store against all the 10 employees. 10 employees tasks completed will be initial state will be no. The moment he completes the task, then that gets converted to Y. Flag will change to Y. So at any point of time, I will go and see out of 10 N's, how many are Y's and how many are N's. From that, I will know where my list of tasks are standing or how many completed, how many are pending. So I definitely need to have a status flag somewhere indicating only two states it will be having: completed, not completed. It can be in progress, it can be in work in progress, so many things. But final result is done or not done. Completed, not completed. So N, no for N, Y for yes. Through that, I will come to know.
This is a flag only, but you need to check that flag again and again. Means, hey, this is a done. I want to know means, let's say first worker means reach to you
Ah,
with the confirmation, hey, I have done or not done.
ah.
How you know it's a first worker only? It's not a second or third worker. My question
Okay.
is different.
I got it, got it, I got it, got it, got it. So now, got it. Now, against, see, each worker will have a unique identity. I mean, in a dashboard, in the dashboard, against each worker employee name or says will employee number, that flag will be displayed, status of the flag will be displayed. So once that get updated, I know, okay, this employee number, let's say we have thousands of employees. So by that employee number, unique number, I'll know the status whether he has completed the task or not. So that means I'm having a unique identity for each employee or each task also. But the status is common. N or a Y is a common thing, but against each employee, a unique identity will be assigned.
Okay, let me ask in a different manner.
Right.
Let's say you are a professor in a class. Okay,
Okay.
and you some of your student
Ah,
want to go outside.
okay.
Okay, and you will how you will give a permission so that when they come back,
Ah,
they can means you can identify those are the same student with
ah,
we means who those go outside with your permission, not without
ah,
your permission. How
got
you
it. Got
will
it.
how you will make sure that?
Okay, so whoever is going out, their student ID, I will mark it in a small piece of paper as out, out, out. Three people went out. Out of 10 students, three people went out. Their numbers, a unique ID will be there. I'll just mark it as O, 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 out. The moment out of three, let's say now somebody comes after 10 minutes. So I will tick it as in I. So another two are still not coming. Now, let us say by chance the fourth person comes who was not in the attendance list, but he's coming as if he went out. So, but when I see those numbers, his number is not there. Who has been inside the class and went out. So I can flag him off. "Hey, boss, don't come inside. You are absent." But the remaining two, when they walk in, I know, okay, oh, these two numbers are pending for coming into the class. The moment they come in at different times, I mark them. So three went out, three went in. One scenario. Other scenario, out of three, two came in. The third number didn't come in at all. Full day, he didn't come in at all. So I'll be knowing by that. So that means still my answer is like each student will be given a unique identity. Based on the identity, I mark them whether out or in.
Yes. Yes, this is one way.
Ah,
Another way, this we
ah.
will give a one token to that students.
Oh, okay, okay.
Hey, we have means in our college there rule at a
Ah,
from one class only five students can go
oh,
outside with a
oh,
permission. Yes, sir.
okay, okay.
What we will do, we
Ah,
will not keep the identity, their
ah,
identity. We will give us, you can say this token to them.
okay,
Hey, you are go outside. This is your permission token, which you
okay.
can use on your college gate, or if someone asks you, hey, what you are doing outside,
Ah, ah, ah,
then
ah.
you can show this token.
Oh, okay, okay,
Okay.
okay.
When you come back, then you
Ah,
need to show this token. Let's say that time you are not available in class.
ah, 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 ah.
Maybe let's say a student want to means go for washroom,
Okay.
and there is no time for
Ah,
washroom.
ah, ah, ah.
Means maybe they at a last means end of your lecture they want to go to
Hmm, hmm,
washroom. Am
hmm,
I right?
hmm, hmm, hmm.
Then in when they come back to
Okay,
join a class, then your class has been changed and you are not there.
okay.
How they will means prove they will go
Oh,
outside with your permission.
oh, okay, okay. Beautiful. Okay, nice, very nice example you give. Okay, fine. Okay, okay, okay.
Makes sense.
Right, right, right. Very much clear. Yes.
Because in synchronous communication, you cannot predict. You
Ah.
cannot predict the order. You cannot predict that. Maybe you also change.
Hmm, hmm,
Bro.
hmm, hmm, hmm.
Then context has been changed. How you will identify the thing?
Yeah, yeah, correct. Oh, this I didn't think of. Oh, beautiful. Okay, okay, okay. Correct.
Now you understand?
Yeah, yeah, yeah.
Okay. Now why? Synchronous communication. Simple
Ah,
to understand,
hmm,
easy for direct user interaction,
hmm.
but increase coupling. What you understand from coupling?
Uh, General term is like together. That is okay. I'll tell you coupling. We say tight coupling, loose coupling. Uh, okay, two events going hand in hand is coupling. Independent events are called as decoupled.
Okay. Okay. Could you give me any example? Simple example.
Simple example, coupling. Okay. The same example of students going out. The moment the student decides to go out, now you are going to give a token to him. So now
No,
between,
no. Simple example. This is a different scenario. Coupling
okay,
and this is a different scenario.
oh, okay, okay,
Don't just think
okay,
about your family.
okay,
Make
okay,
sense?
family. Ah, right, right, got it. Okay,
Yes.
me and my children are, okay, me and my wife are coupled, whereas me and say my cousin, somebody, for relative is example of a decoupled relationship.
Right now we're talking about coupling only.
Ah, okay,
You
coupling.
just focus on a coupling
Okay,
only,
okay,
not
very
decoupling.
okay, well, so only coupling, for example, my wife and me and my wife are coupled.
Yes.
The relationship is coupled, tightly
Yes.
coupled, we can say.
Yes. So if relation means coupling is not there, then means family is not there.
Family is not there. Ah, right, right. Okay, correct.
Makes sense.
Yes, 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 yes.
So increase latency.
Mm.
Let's say you guys need to go to a party,
Ah,
and the family is a family party,
mm.
and your means wife is means taking some time
Ah,
to dress up
yes,
or
up
make
and
up
down.
the
Ah,
things.
yes, yes,
You
yes.
cannot. You need to wait.
Wait, correct.
In that case, this latency will be increased.
Increased. Ah, waiting time will be increased. Correct, correct. Right.
Makes sense.
Yes.
Okay, can create crashing failure, cascading failure.
One after the other, like failures happening in a sequence, one after the other, cascading failures.
Yes, let's say it means something is went wrong, then your wife will inform you, then you will communicate with means you this, or you can say think of your child is informed to your wife and your wife informed to you. It's a
Mm-hmm.
cascading.
Cascading effect. Yeah, correct.
Okay.
Right.
Now asynchronous communication.
Asynchronous. Okay. Okay. Improves scalability. Yeah. Okay. Asynchronous is like happening in the background is what we told. Improves scalability. Improves resilience. Okay. Resilience. Improves scalability. Yes, I got. But improves resilience. Mm,
Okay. So improve scalability, resilience means you are, let's say you have a one worker. Okay. And that's doing everything. Makes
mm,
sense. And
mm.
now you have 100 workers, so you can increase the worker there.
Okay, okay.
So it's improve your resilience. Now you
Oh,
understand
ah,
scalability and resiliency.
right, 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 right.
You can say reduce user facing wait time,
Hmm.
but introduce eventual consistency and operational complexity.
Complexity, okay. But introduce eventual consistency, okay, fine. And operational complexity, okay, okay. Introduce eventual consistency, okay. In the plain terms, overall the consistency is maintained, whether single user, hundreds of users.
Yes, yes,
Melee, melee. Okay, so that's what. Whether one user or thousands of users, consistency is maintained. Okay,
yes, yes,
and then yeah, as and when the users are increasing, definitely the complexity also will increase. The overall complexity of the work will get increased, but it works consistently, even though it is increasing in all aspects. The work continues consistently.
yes. So when we need to use what?
Okay, when
So immediate user feedback is needed.
yes, correct.
The action must be complete before moving forward.
Forward, okay.
Dependence is
Right,
reliable and fast.
fast, correct, okay.
This work is long running.
Hmm.
Work on a can happen
Right,
later.
huh.
Multiple system need to be react.
React,
Background processing is required.
required, correct, yes.
Real time example.
Huh.
Sync, check restaurant availability. They
Huh.
want
Huh.
instant reply,
Yes,
validate payment and confirm order.
yes, exactly.
They cannot wait for
They
this.
can't wait, yes.
Okay, send notification,
Async,
assign delivery partner, update analytics.
huh.
You can do this in a background.
Background, yes.
So let me go there. Any you can say concern or anything which you need to discuss regarding these uh, point which we discussed.
No, I think you are explaining in a very lucid manner, simple manner. So I'm able to relate that.
Okay, so now means here user will you can say do this. Let me let's ignore this because right now it's not showing us a fine way. No worries. Let me try again. No, it's not working in a fine. Okay, we are good there. Now, meaning the user get a quick response
Hmm.
and response and background work continuously later. So
Ah.
engineering mapping, synchronous, REST, gRPC, and asynchronous Kafka, Rabbit, MQ, SQS pops up,
Okay.
which you can use for this asynchronous.
Oh, oh, okay.
And now we need to move to our next part,
Ah,
request versus event-driven flows.
ah,
One service directly asks another service for something and wait for the result.
Result. Okay.
So event driven, one service publish an event and another service react
Independent.
independently.
Right. Right.
So why?
Ah, ah.
Simple and direct, good for queries, but tightly coupled services.
Services.
Okay, reduce direct dependencies, event driven. Allow
Mm,
independent scaling, support multiple downstream reactions, but require better observability and adaptancy.
mm.
Make sense?
Right. Right.
User request response when one service directly need data from another.
Mm,
User waiting for immediate output.
mm.
The operation is query focused.
Right.
Use multiple services must react to change.
Mm.
Means multiple subscribers are there.
Correct.
Okay, scalability is important.
Mm.
Decoupling is important.
Yes.
You want a loosely coupled system.
Right. 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 Right.
Data flow workflows are distributed.
Yeah.
Real time example. When order replace payment, service should react.
Correct.
Delivery service should react.
Right.
Notification
Right.
service should react.
Right.
Analytics service should react.
Right.
Which is not possible in a request response.
Correct. Correct.
This is a perfect event driven
Okay.
scenario.
Yes.
So, meaning each service directly depend upon next one.
Correct.
The producer does not need to know every consumer. They will
Mm-hmm.
produce, they will publish the thing.
Right. Right.
They don't know means same thing here, request to response. It's a REST API this. Okay.
Right. Right.
Now data ownership and data movement. Data ownership means one service in the source of truth
Mm-hmm.
from where they will get a data or a
Correct.
specific type of data.
Right. Right.
Let's say cloth from where you will get material from where you will get.
Right.
Make sense?
Yes. Correct.
Data movement, how other service or use that data.
Right. Right. Right.
If ownership if ownership not clear, multiple services update the same data.
Ah.
Inconsistency appears.
Mm,
Debugging
mm,
becomes difficult. Trust
mm.
in data reduce.
Ah.
Data owner should be defined during system decomposition, before API design,
Okay.
before database design, before deciding communication pattern.
Okay.
Okay.
Ah.
Order service on order state. Payment service on payment state.
Right.
Delivery service on delivery assignment.
Mm.
Notifications should not
Modify.
modify order data directly.
Okay. Okay. Okay.
Okay. Only order service on data, state, and other confused updates. So, meaning multiple service directly touching another service data creates chaos.
Correct. Yes.
Okay.
Right.
Important rule. A service not directly update another service data.
Ah.
Use API event, replicate real model projection.
Mm.
Handling partial failure in communication. Partial failure means one part of the distributed system failed while
Ah.
the rest continue
Continue
to
to
work.
work. Okay. Okay. Okay.
System do not fail at once
Mm.
because everything is distributed.
Correct.
Payment work but notification failed.
Mm.
Order sale but analytics failed.
Wheels.
Queue is available but one consumer is down.
Down. Okay. Okay. Okay.
This is a normal behavior, not an expectation.
Okay. Okay.
Failure handling must be designed
Mm.
alongside communication pattern, not after system development.
Correct.
Payment success but SMS verification notification failed. Correct behavior. Order remains successful.
Ah.
Notification is retried.
Mm.
Failure is monitored.
Mm.
User is not charged twice.
Ah. Deepak, one small doubt regarding the failure handling. Just go up.
Yes, yes.
Failure handling, little up, I think, failure handling. Here, failure handling must be designed alongside communication patterns, not after system development. Okay, this statement I understood. But are we going into the how part of it or?
Definitely. As we decided,
Ah,
one part we will discuss the concept, and the
ah.
next part we will discuss how.
Okay, fine. Okay, fine. Then got it. Okay, okay.
Because we divided this each module in 2 days, two
Ah,
hours,
ah, ah.
and in a 2 hours, first we will discuss the concept, and next we will do the how.
Oh, beautiful. Because you are touching the very most important topics, which if we really talk about it in the interviews, definitely they'll be knowing that this guy knows more. Because generally people don't think of failures; they always think only success. But failure handling is equally important.
Yes, everything is important.
So okay, I'm more curious about that.
No worries, we will, as we discussed,
Ah, ah,
means we will do both the thing
okay.
concept,
Ah,
and after making concept, we will do a brainstorming on how.
right, right.
And that's why with the how you will do a practical.
Yeah, yeah, right.
Am I right?
Right, right, right.
And repeat the same operation often. Concept repeat the same operation after temporary failure.
Failure. Correct. Okay.
Reprocessing, replay work safely,
Hmm.
usually for
Recovery.
recovery.
Okay.
Independence running the same request multiple times should not be create duplicate effect.
Idempotency. Okay, fine.
As I told you, we will go through this terminology again and again.
Okay. Yeah.
Because these are base.
Right, 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 right.
Stop waiting after a limit to prevent resource execution.
Hmm.
Del letter queue. Store failed messages for later inspection and recovery.
Oh, okay. Oh, that is dead letter Q, is it? Okay, okay, okay.
So comparison summary table.
Hmm.
Response system means in a synchronous, immediate, deferred.
Hmm.
Coupling tight, loose.
Ah,
Latency higher for caller, lower
ah,
for caller.
hmm.
Make
Scalable.
sense? Scalability lower, higher.
Ah,
Failure impact more cascading risk.
ah,
More isolated example login validation notifications.
right.
So request response.
Hmm.
Interaction, direct call, event publish.
Right.
Coupling higher, lower.
No,
Best
yeah.
for queries,
There is
reaction workflows.
close. Yes.
Scaling harder, easier.
Hmm.
Flexible, lower, higher.
Yeah.
Okay. Breakdown. User facing validation can be synchronous.
Hmm.
Multiple service reaction can be asynchronous.
Hmm.
Order service on
Order.
order data.
Correct.
Downstream service react independently.
Yes.
Failure in one side,
Should
path
be
should not break everything.
everything correct.
So these are the some interview question bank with answer.
Okay. Okay.
When do you prefer synchronous communication?
Hmm. Okay. Yeah.
When feedback
Immediate.
is good. Yes,
Okay.
Go ahead, go ahead.
Okay. Okay.
You're on.
Okay. When immediate equality. Okay, correct. When is asynchronous for long running tasks, background work, and workflows that can tolerate delayed completion, correct. Why are event driven system more scalable? Because producers and consumers are loosely coupled, correct, and can scale independently, right? Right. What risks come with synchronous chain? Higher latency, tighter coupling, and cascading failures, correct. What is data ownership? Yeah, clear responsibility for the source of the truth of a specific data domain. Beautiful. Why should service not update each other's data directly? It creates tight coupling. Okay, okay, okay. Fine. How do events help the data movement? They allow state changes to distribute without shared database. Okay. Partial failure is failure of one component while the rest of the system work operational. Correct. System tolerate partial failure because fine, distributed system do not fail automatically. Okay, fine. How do you retire? How do retire retries? Okay, retries repeat the same action after temporary failure while reprocessing safely. Okay, work later. Idempotency, yeah, very important. Okay, fine, got it. Okay, time out. Okay, okay, this document I'll go through. You have given me anyway. I'll go through this, Deepak. Never I have got this type of document anytime.
Thank you. Let me just a minute.